also contribute to the Godot game engine for many years. And I believe that we should have more open standards with that are high quality standards that anybody can implement that allow you to make more interesting game types of game assets. And one of the types of game assets that I'm particularly interested in because I think it's just really cool is the type of game assets you find in Super Mario Galaxy. And in that game, for anybody who's not familiar with it, there are these tiny planets. They're only like, a few dozen meters across, and they have different gravity directions. So you could platform around on them, and some of them will be like flat platforms, some of them will be spheres, some of them will be discs. And some of them are all sorts of custom wacky shapes. And the way that this works, the way that the game does it is quite well known. It's not like a secret how they do the gravity. The game has been like studied and stuff, and you can already do some of this stuff with the gravity inside of Godot engine because it comes built in with with the area nodes that are able to use either directional or point gravity. But some of these gravity shapes are a little bit more complicated than that. So what I'm proposing here is physics gravity. It's a glTF extension that implements gravity, and this comes with a an example implementation inside of Godot engine that can import into an extended version of the area gravity system. It does require an engine pull request at the moment to allow for these more types of gravity shapes. But anyway, there's a whole bunch of types of gravity. There's the simplest gravity would be like a sphere. So this example has a planet with a sphere. The gravity type is point, and it gives this amount of gravity, and it has also a unit distance that is like the distance to the surface from the center. And all these things are used to calculate gravity. So that's this would be more of like a realistic type of gravity, where you could maybe orbit around it if you wanted to, or whatever other things you want to do on a realistic Earth. And then aside from that, there's also gravity fields on individual nodes. And for those, we have a type that specify what type of gravity you can have. And the type can be a bunch of things. It could be directional, point, disk, torus, line, or shaped. And so these things determine what the gravity attracts towards. So it's not actually the area of effect of the gravity field. The area of the effect of the gravity field is determined by the shape of the trigger volume, which is important to Godot as an area node, but represented in glTF as a trigger shape. And this determines once you are in that volume, where do you get pulled towards? So a point will just point you towards the center point. So that'd be like the center of the planet. Directional is if you just want like a unidirectional field that is always pointing one way, one global direction or local direction. Then there's also some other ones like disk, torus, line, and shaped. And with all six of these types, it is possible to recreate any type of gravity that you would find in the game Super Mario Galaxy. And as a demo for that, I have this pulled up right now. This is a test scene that I made and imported into Godot engine. So all of this is running off of the glTF. The only Godot code here is the skybox, because unfortunately there's no skyboxes in glTF, and the player controller. So I can move around with the player controller here. And I have a bunch of colorful pedestals that allow me to test various features of gravity. So these two gravity fields here, both of these test directional gravity. They test it in two different ways to accomplish the same effect. One of these is pushing to the side, and one of them is pushing uh, down locally and overriding the global gravity. So you in the gravity fields, you can either choose to add to the global gravity or override it. So there's already gravity. If I jump, I'll go up and then I'll go down. So you can either choose to push to the side and keep that alt gravity, and then the net result is them added together at an angle like that, or you can choose to replace the gravity, and then you'll just be pointing down. And I also have these other two pedestals here that demonstrate the same thing, but with setting the gravity to zero. So one of these will set the gravity to zero in that field by just setting it to zero. And one of them will do the same thing, setting it to zero by instead adding an upwards gravity that negates the moon gravity. And that's just to showcase that the entire moon scene is one glTF. So all of these gravity fields here, the cube pedestals, the mesh for those, the mesh for the moon, and the gravity fields for these are all contained within one glTF file. So one for all of it, and these are just individual glTF nodes, and so this uh, you can parent them in the hierarchy however you want, but like yeah, they're just nodes. All right. So then there's other shapes here too. So here I have this cone, and this cone showcases the combination of a line gravity field and a directional gravity field. So this actually combines pointing down towards the base of the cone and the line pointing towards the center of the cone. And that the effect that gives you is that it's a little bit hard to see, but this always pulls you towards the surface of the cone, and it even works if you go beyond the cone. So it still tries to pull you towards what would be the surface if there was a cone. If there was more cone there. All right, and here's an example of a sphere. This is a point gravity field, so I can just jump onto the sphere, and then I can walk around on the sphere. And the sphere is very simple; it just pulls me down towards the center, and the player controller is designed to respond to the gravity field, so it'll rotate and be pulled towards whatever gravity field is active. Over here is a test of an aligned gravity field. So this showcases how lines can be used to walk along the surfaces of capsules. So, because a capsule is the type of mesh where a it's formed by basically taking a line and puffing it out. Like it's like how a sphere is taking a point and finding everything within a certain radius of that. This is taking everything with a certain radius of a line. And so that works wonderfully. You can walk around on this capsule, you can walk around on the end, you can around on the little connecty bit, and it all works. And here, this orange one is a torus. So this allows you to create a torus shaped gravity field where you can walk around on it like it's a donut. And I accidentally jumped a little bit too much there, so I'm actually orbiting it right now. I need to wait until I come to a landing before I can actually walk around again. There we go. All right, now I can walk around. So I can walk around on this torus, and what this really is doing with the torus is, again, there's a simpler shape underneath here. It's actually a hollow circle that it points me towards. So if I'm in the middle of the circle, it points me out towards the edge. And if I'm on top, it points me that way. This side, this will be that way. But you may also wonder, what about non-hollow circles? Well, that's another very common shape in Super Mario Galaxy. It's in fact used on the first level. So this showcases a disk gravity field, which points towards a filled circle. So if you're above the center, doesn't it pull you towards the edge? It pulls you just straight down towards what would be the surface of that circle. And even though these are using circles under the hood, I called the gravity shapes disk and torus just to make it extra clear what these are meant to be used for. Because if I called them hollow circle and filled circle, that would be kind of confusing. Uh, But anyway, I can walk around the edge, and it works. And you can use this to create little disk planets. And there's two more shapes in the demo here. Here I have a ramp, and this ramp is created with a combination of a few different gravity fields. This is showing like how you can combine gravity fields for effects. So there's a directional gravity field at the base here. Then this little connecty bit, there's this kind of wedge shape that is formed by creating a line gravity field that like runs parallel to the surface here, and it has negative gravity. So the line is actually pointing. You normally align gravity would point you towards the line. This is pointing you away from the line. So there's a line parallel to that surface. Oh, I just fell, so I'm going to reset myself. Um, always have a reset button when you're doing a demo. So you can walk around on this, and yeah, it all kind of works as you would expect. And then here I have a cube shaped gravity field. So another feature is that it allows you to use any physics shape as a gravity attraction point. So for example, this allows me to create a cube that I can walk along the surface of. So as you can see, the cube has round edges, but you can imagine there's a second smaller cube inside of it with sharp edges, and that's like the mathematical object it tries to attract you towards, just whatever's the nearest point on there. So if I go over here, then the closest point is the edge of that cube, edge of the one of the faces of the cubes. So I can walk around on that, and I could also go to the corner, and that will attract me towards the corner of that hypothetical mathematical inner cube that is defined in the glTF file but not visible to us. So anyway, I could walk around on the cube, and it kind of functions as you might expect. And from somebody who has not played Super Mario Galaxy, you might look at this and wonder uh, if since the visuals it looks like a cube, so maybe you should just use the mesh for figuring out the gravity. But that's actually very suboptimal for many reasons, including intent complexity of calculation, and also the freedom of the level designers to allow the visual geometry of the level to be decoupled from the gravity of the level. So, even though these are pretty simplified shapes, in an actual game with actual assets, you could make much fancier meshes, however you'd like, and then the geometry of the gravity area effect is defined by the trigger nodes, and the shape of the gravity effect is determined by the gravity properties. All right, and anyway, that is the demo of everything in this scene. I do have one other test scene that I can pull up as well. So here, anyway, I'll show you here in the editor uh, on this scene as well. So this is running off of a glTF. So if I try to open it, it'll tell me like, "Hey, this isn't a Godot scene." Um, but I can look at these different things, and there's these area nodes with gravity fields, and you can see that there's these shape nodes that get imported from the OMI physics, and what may be migrated to Chronos physics in the future. And this just shows you the area of effect. So anybody standing within this volume here will be affected by the gravity, and then the gravity is determined by the settings here on the gravity nodes. There's these options here. So for the line gravity, you can see the line points. Anyway, all these test scenes are available to download if you want to come check out the repo. There's also a repo just for this Godot project that has like an example of how this works. And now let me go to the other test scene. Um, test Earth. So this is a simple test scene that showcases the Earth, which is a not the full size Earth, of course. This is a 1 millionth scale Earth. So the actual Earth is a million times bigger than this. But anyway, It's the Earth with normal Earth gravity, and there's also a ramp here so that you can get off the planet. And I could actually just walk to the side here, and it makes my feet point down because that's where the gravity is attracting towards. And I actually orbit the planet because at this point it's just regular old Newtonian physics driving my motion. Now, Godot's physics engine isn't perfect, and there's some precision loss from rotating the player controller and the center of mass not being updated correctly. So it does actually drift a little bit with the orbit here, but you just generally speaking, you can see that it behaves like an orbit. It gets slower on the highest point, it gets faster on the lowest point. And this is all done by specifying the unit distance property. So unit distance allows you to specify the distance from the attraction point that is considered like the point at which the number you enter for gravity is the actual gravity. So on the surface, I specified the planet's gravity is 9.8. So on the surface, the gravity that you experience is actually 9.8. And if you don't have a unit distance set, it's 9.8 everywhere. But if you do have a unit distance set, it's only 9.8 at that distance, and then you can get closer and the gravity increases, or you get farther away and the gravity decreases, just like real life. So you can choose if you want to have a constant strength gravity field, or if you want a gravity field that behaves realistically, and if so, at what distance do you want that gravity to be the number you entered? And anyway, that is everything. Does anybody have any questions?
Yeah, definitely. I guess first is like, what's the best way to provide feedback?
Yeah, so the best way to provide feedback, there's a couple ways. You can come to OMI glTF extensions group meetings, which are every Thursday. For anybody here who's not familiar with that, the Wednesday morning, well, it depends on your time zone, but the early Wednesday meetings here at OMI are more of a general meeting, and then we have a more technical GLTF focused meeting on Thursday. So everything on screen here, like we would debate like every sentence of these specifications in the more technical meeting. So you can come to there. You could also come to the extensions repo. You can read it to get an understanding of it. And if you would like to raise an issue, if you find something wrong with it or something you'd like to suggest a change, or you have a question, you can come over to the issues tab and you can open an issue, whatever you'd like. You can also go over to the pull request tab and see some in progress stuff that will be coming into this repo in the future. I just recently worked on physics materials and filtering, so we'll probably be discussing that at the tomorrow's meeting. So yeah, there's a lot of ways, but yeah, the most major and two notable ways to give feedback are to come to the meetings and come to the GitHub repo.
Cool. Thanks, Aaron. This stuff looks awesome.
Great demo, thank you very much.
And if you're on the GitHub repo, if you're not familiar with it, uh, the main thing you want to do is go into this folder here. This is extensions slash 2.0. And then here is a list of all of the extensions that OMI has worked on so far. So there's audio emission, various audio types, link and personality haven't been worked on in a bit. Then there's a few ones for physics, bodies, gravity, joints, shapes. And there's also game specific ones like seats and spawn points. And we will work on expanding this in the future. I don't have a timeline on this precisely, but in the next couple months, I would like to add vehicle extensions to this list. So if you want to participate in the discussion of how driving vehicles around imported from glTF files will work, then please do come to the meetings and discuss these things, because I very much am seeking input. I don't want to propose anything unless I have a good understanding of it and I'm confident that it's actually good. Because the only thing worse than not having a standard is having a bad standard, and then everybody's stuck with that. You have to have good standards. All right, well, I will stop streaming because we are at the meeting time. But if anybody has any more questions, you can keep asking.
I guess a real quick one. Does it support negative gravity values?
Yes.
Cool.
So you specify the gravity direction and the gravity type and stuff, and you can give it a negative gravity number. Yes, that's actually how the ramp works. It uses a little wedge in the middle. That's an inverse line gravity that pushes you away from the line. Yes. So the gravity is designed to work from any glTF file, and you can indeed have objects with gravity that interact with each other. And the way that it determines which one takes priority is there's a number system for priority where you give it an integer of like how important this object is. And so that does kind of mean that you have to like the files have to be good stewards of their own numbers for priority, and give reasonable numbers so that they hopefully won't conflict with each other. But there's guidelines specified inside of the gravity extension that recommend like uh, that you use like positive thousands of number for gravity fields, so that there's always space in between those numbers to like insert a new number. I don't know if I'm explaining this right, but the point is that there is a system for determining the priority of gravity fields when multiple files come into contact with each other.
Awesome, thanks. I think with permission, perhaps doing a brief edit and just making sure that everyone's happy with how it looks, then we put it on the YouTube channel. I'd like to do some snippets, like short snippets to go on Twitter, and then work it up into a blog, hopefully within the next week. So this is also a test for us to easily spin up content without burdening the people doing the actual dev work. So you give a demo in what's comfortable for you, and then we use what we have and build content from that. So that's the experiment we're running at. Yeah.
It sounds good to me. I do have limited time to dedicate if I'm also working other stuff. So